All right. So in the last session, we were discussing the wedges and arcs. So I told you that an wedge is a filled arc. Okay. And there are four ways or four modifications that we can do to an arc or a wedge. So this was for introducing an arc into the plot. This was for introducing the wedge. So if you fill the arc, it becomes a wedge. Then we discussed two more possible modifications. One is the annual wedge. Annular wedge would introduce a filled area as well. So there are two more extra parameters that will be taken. One is the inner radius and the second is the outer radius. And then finally is the annulus function. So which will give you filled rings as well. Now let's see what this difference is all about. Let's practically visualize it. So this is for simple arc. This is okay, x and y coordinate, center coordinate, radius specified, start and end angle. So let's see what comes out. So yeah, there are we. Okay, so if we can see that three arcs are there, one, two, and three. Okay, three different arcs because I have specified three values and there's a radius of zero point 0.1. It's the zero point 0.1 radius. Okay, and then this is for wedge. So I told you that wedge is basically a filled arc. So there are some extra parameters like direction we have given. That's an option that if you want to mention direction or not. And then this alpha is an extra parameter because I want to fill this arc. So I have to tell what is the level of or the darkness levels of the filled area. Okay, so let's see how it comes. Let's see how it comes out. So this is how, see, the arc is now filled. Okay, so earlier there was only arc, this was only the arcs. Okay, and this time we have a filled arc. And then there's the angles are different because when we were having a simple arc, this was the simple arc, so there was a difference of angle. All right, so here start angle was zero point 0.4, 0.4.8 was the end. uh, Sorry, yeah, clock, sorry, it's the difference is because of the clock factor. Since I have given extra optional parameter direction because I want to render my wedge in a clockwise direction, that's why the difference of direction is there. Okay, and there's a color difference because the this is the way it has been, the color has been mentioned. The third function that we discussed was the annular wedge. So where I told you that it is similar to, again similar to arc, but it will give you a filled area. So there are two more extra parameters that we have put up. So the parameters are the inner radius, that's an extra parameter, and the outer radius, that is again an extra parameter. So let's see how it differs from the remaining two. Okay, let's see what comes out. Yes, so now you can see here. See this, it's a filled area. All right. So filled area, I have mentioned the inner and the outer radius as well. So since inner and outer radius have been mentioned, so accordingly, if you see how the inner and outer radiuses are there, if you compare this, the these three arcs, the very first plot, simple arcs, and this, the direction is same for all three. This is a simple arc. This is an annular wedge. So where I have, it's giving me a filled area, and this was a simple wedge. Okay, this is a wedge, filled wedge. Since I gave an additional option of clockwise direction, so it has become a little tilt. The shape is different. This is an wedge. The shape of wedge is different than arc. Okay, and if you see here, this is a proper arc. And then finally, the fourth function that we have discussed was the annulus glyph. So where I told you it will give you the filled rings. Okay, let's see how this function differs and what different plot it will give to us. See, now it's a complete one. Can you see this? This is a complete one. It's not half. It's completely filled, and complete circle out is there. See, all the three arcs completely filled. So this is giving me a filled ring. That's what we specified, that if you use annulus, it will give you a filled ring. So, instead of arc, the arc has been extended further to form a ring. So when you're forming a ring, the inner and outer radius is obviously there, so that we have mentioned. Okay, so this is simple arc, this is wedge, this is annular wedge, so there's a filled area with inner and outer radius, and this one is your ring. So arc has been converted into a ring with the help of the annulus function. All right, so this is how you can produce different kinds of arcs and wedges, and it's uh, can beautify your plot, or can help you in visualizing some especially some mathematical facts, if you're looking into it, or the scientific facts if you are working on it. So now, after this session on arcs and wedges, there is something which Bokeh provides extremely useful and exclusive, which is the specialized curves. Now there are few types of specialized curves which one can perform using Bokeh, and one of them is the Beizer. Now it's a parametric curve. It's very well applied in the area of computer graphics, and this specialized curve, or the Beizer curve, it is specifically used for designing of computer fonts or the animations. So, the different fonts that you see, the Times New Roman, Arial, according to, whatever font you choose, the shape of the text changes. So Beizer is one type of application, that is a specialized curve, that is, you know, helps in designing these fonts or the user interfaces that you see, or for smoothing the cursor trajectory. If there's a trajectory graph, you are, let's say, in space functions, you are analyzing a trajectory. So, if you want to smooth it, then Beizer curves are very useful. So it's the application of Beizer is very well known and acknowledged in such industries. Then vector graphics, Beizer curves, they can model smooth curves that can be scaled indefinitely, so they can help in smoothing the thing. And then there's a term path, which is very much used in Beizer curves. So it's a combination of linked Beizer curves. So when many Beizer curves are linked together, then a path is formed. So we call it as a path. The technical name is path here. And then the Beizer function. This is how we use the Beizer function: Beizer, and then the open and the closing parenthesis. So Beizer is an extremely useful and high-ended specialized curve that is possible with the help of the Bokeh library. Uh, Now, to draw a Beizer, there are a lot of parameters that needs to be defined. A lot of control point. We call them as the control points, ending points, and the starting point. So there has to be a starting point of the curve. There has to be ending point of the curve, and then there are control points which will control the movement of the curve in the plot area. Otherwise, it would be indefinite. That's what I said here. That they can be scaled indefinitely. One of the major usage of Beizer curves is that they can be used to smooth curves, and that then scaling can be done indefinitely. So if you want to stop that indefinite, you have to mention those control points. So x naught, which are the starting point, x coordinates of the starting point. Similarly, y naught are the y coordinates of the starting point. Then x1, y1 are two more parameters, which are the x coordinate of the ending point and the y coordinate of the ending point. Then there are four parameters like Cx and Cy. So these are the parameters for the control points, the first and the second control point. Control points are very important in Beizer curve, otherwise it can be extended indefinitely. Okay, so these specific parameters needs to be mentioned when you are putting the Beizer curves. So let's take this an example. So I assume x equal to 2 and y equal to 4. That's my assumption. Okay, and then these are the what I have mentioned, the x points, the xm and ym and yt, all these things are mentioned. These are the five further parameters that I have mentioned. Okay, so this fig equal to figure, so that's basically mentioning the parameters of the plot area, how the entire area of the plot, what should be my width, plot height, width, and all that stuff. So then the fig dot Beizer, that's the function we use. So I need x naught. What was the x naught? The the x coordinate of the starting point. So x naught is equal to x, then y naught is equal to y. Y naught is the y coordinates of the starting point. Similarly, x1 and y1. So x1, y1 are also there, which were the x and y coordinate of the ending point. So those also needs to be mentioned. So this I have mentioned. X1 is xpo2. This is my x1. Y1 is equal to y. So that's equal to 4. Okay. Then CXO, CYO, control points, X coordinate of control point and the X coordinate of the first control point. And similarly, CYO is the Y coordinate of the first control point. That's CYO. Okay. And similarly, CX1 and CY1, which are the x and y coordinate of the second control point. All these things need to be mentioned if you want to draw a Beizer curve. All the parameters have to be there, otherwise Beizer would not be viable here. When you can have some additional parameters like line underscore color, so what color of line you want and the width of the line, and then finally the show effect. And this is your Beizer. Okay, you can see this is how the Beizer works. So x naught was equal to x, so which is equal to 2. So you can see the starting is at 2, and y naught was equal to y, so y was 4. So the first point is 2 and 4. Okay, this was the x coordinate of the starting point and the y coordinate of the starting point. So my starting point is x not equal to x, that is 2, y not equal to y, that is 4. So x 2, y 4, this is my starting point. Okay, and similarly our ending points were x1 and y1. Okay, so x1 I have mentioned, which is this x plus zero point 0.4, and y1 I have also mentioned. So accordingly I can design my ending point as well. Okay, so this is very important, how you basically do that, where you want to place the end. That end is very important. Okay, so accordingly these parameters have to be fixed, and this Beizer curve would be right there in front of you. So you can variate these parameters, and different fonts can be decided, can be designed for your computer graphics. And that's where the major application of Beizer actually lies. uh, Instead of Beizer, you can have a quadratic shape also, so it will add a parabola glyph to it. So in a parabola, these are the parameters, again almost same parameters, except one or two differences. That CX1, CX1 control points are not required. CX1 and CX1 X control points are not required in a quadratic. So we have not mentioned the entire command is same what we have given in Beizer here, except that CXO and CX1, the control points for this the X coordinate of first control point is not there. Okay, and the X coordinate of the second control point is also not there. So control points for X coordinates are not required. Rest all the things are same. So instead of Beizer, it will give you a quadratic shape. That's the difference, a little bit of difference that you need to introduce if instead of Beizer you want to put up a quadratic shape onto your plot. So setting ranges will come later. Let's see how the things go in the Jupyter or in our interface. So we are going with the Beizers. Okay, let me mark it as a heading for your clarity. So Beizer. So this is the simple command for Beizer. Okay, all the control points have been mentioned. X1, Y1, X0, Y0, CXO, CX1, CX, CY1, CY0, and all that stuff. And if you run it, you get your Beizer. Okay, these are the starting control point, ending control point, and all that stuff. Quadratic, if you want to introduce, the only changes that two parameters have to be removed. So CXO and CX1, the X coordinate control points are not required. So in that case, it will give you a quadratic one. Okay, so this is for the quadratic. Let's run it and let's see how this comes. So if you see it carefully, this is what we get. Okay, the quadratic shape. All right, so that's good enough in this session, and all the best and happy plotting.